extremely exciting AI revolution, that we're very, very excited to share with you. As most of you know, we were teaching computers what to see. Now we'll teach computers to say what they see, and ImageChat is all about that. So let's just dive right in and see what is the problem that we're trying to solve. So the world has more than 45 billion cameras. About 20% of those cameras need to be monitored for critical insights. And as we know, most of the industries that we work with, whether it's manufacturing, retail, smart cities, logistics, warehouses, and actually public sector, Department of Defense, state and local departments, all of them have put many, many cameras out there. Despite putting many, many cameras out there, we have millions of cameras, as you can see, storing millions of video in storage, and then, of course, having millions of people monitoring those feeds. Now, despite making all these investments, very little gets done. And the problem is, most of these cameras are dumb, they're not intelligent. The streams are flowing right through into NVRs and actual recording systems. And then we put these huge amount of people trying to look for anomalies or critical insights. All that infrastructure is out there, but again, as we know, very little gets done. What do computers really need? They need deep AI vision for deep understanding and decision-making capability. So what if we could actually put some AI vision and made these cameras intelligent? That is the problem that we are trying to solve. We are actually teaching computers what to see. And how do we do it? We actually have a Chooch platform that is being deployed in two ways out in the market that we're going to actually share with you that makes these cameras intelligent. And it has to be done in a plug and play way. So without any disruptive force to the current infrastructure, your DVR systems, and your security operation centers or operation centers, how do you make it in a way that could be plug and play? Which is take the same camera streams and run them through the Chooch engines, both through the studios, through the inferencing engine and the analytics, so that now people are more efficient. There is much higher productivity, very, very high levels of increase in revenues, very, very high levels of loss prevention that's taking place. So again, simplifying complexity is what we do when we actually make these cameras intelligent. How do we do it? We actually have two tracks that our clients and our partners can go down. The first is what we call as the create track. The create track is where you take the AI Vision Studio, build your own AI models, bring your own data sets, you run it through the inferencing engine as you put these models into production, and boom, you get the smart analytics, you get the actionable insights. That's what we call as the create track or the create platform. We also have another platform that we actually introduced earlier last year, which again has seen tremendous uptake in the market. Most of the clients actually say to us, look, I like the fact that you have a platform that allows us to do the entire creation, but do you have something called as Ready Now models, which are models that can have typically same day to same week installs that can get us the value in production quickly. It lowers the cost of ownership, lowers the cost of technology, lowers the cost of time to value. And these are what we call as Ready Now models, which are pre-trained AI on pre-annotated data. And if you get actually Ready Now models, you put them through the inference engine, all of a sudden you have smart analytics, you start to actually get the value from all those camera streams that we've been talking about. That is what we call as the consume track. And most of the clients actually have said, okay, you know what, maybe I start off with Ready Now models and then continue to build models. So it's a journey, a computer vision AI journey, where I'm able to make my cameras intelligent and then more intelligent as we move forward. So as you think through what is the potential out there, think about, do I need the create track or do I need the consume track that will allow to make my cameras intelligent? The choice is yours. That choice that we actually extended to our clients last year, both in the commercial and the public sector, translated to the intended results, which is we ended up teaching computers what to see like humans do. So the cameras would detect like eyes would, the computers would understand like the brain does, and then clearly humans would act instantly like humans should. So the goal of teaching computers what to see was actually met in the entire go-to-market fit, product market fit that we've established over the past few years. And again, thanks to your partnership with large-scale Fortune 500, Global 2000 clients, we actually have signed more than 35 enterprise agreements with the best brands in the market in the last 40 weeks. Now, it's unheard of in the history of deep tech AI, where you're able to take a plug and play AI platform, either on the create track or the consume track, and actually start making cameras intelligent. In fact, meeting the objective of teaching computers what to see. That also led us to become one of the leaders in the IDC quadrant, along with the larger players and more established players like Microsoft, Amazon, and Google. I mean, on computer vision, everyone, including very large, analysts like Gartner, IDC, Forrester, and of course, very, very strong media outlets like Bloomberg, Forbes, etc., started actually calling it out, saying that, hey, this is fantastic. Here is a computer vision player who not only has the consume track and the create track, but can deploy on any silicon, whether it's NVIDIA, Qualcomm, Intel, AMD, anywhere on the edge, on the cloud, or on any form factor, including smart dogs, drones, robotic machines, and so on and so forth. So the fact that we were able to translate all the value into real customer environments, whether it was use cases on employee healthcare and safety, whether it was on loss prevention, planogram analysis, whether it was inventory stockout, it was anything to do with anomaly detection on the assembly line. We had these huge references that were actually taken up, and clearly the fact that we could be deployed anywhere on any silicon, on any camera, as long as the camera had the right resolution and the field of view, was actually lauded and appreciated by the best. So why did we think about ImageChat? Why did we think about the next AI revolution? And with privilege comes responsibility. The fact that that we've got that position and we intend to keep it made us think about ImageChat. So why did we create ImageChat? What is ImageChat? Well, about 80% of the use cases, based on what we have learned from IDC, they actually need decisions in actions in seconds. And so when you actually put the Chooch inferencing engine and the analytics right behind those cameras, and you start to actually understand what's happening, you actually have to understand how humans think. Humans see through their eyes, but think and understand in language. So let's say I actually pointed you out to a fire, and I said, can you see the fire? You would see through your eyes and you would see the fire, but your brain would actually spell it out as FIRE in English in this example. So while humans absorb the information, ingest the information, which are camera, video, images, etc., they're actually thinking through in language. So we said to ourselves, okay, if you take in the video streams that's through sight and you attach a large language model next to it, that would actually make it more insightful. So the question that we asked ourselves is, what if humans could interact with images in language, and more importantly, actually have the computers actually ping the images and get the images to talk back? So what if you could actually put a text in front of the AI model, and actually, depending on the context, you could ask the question and the prompts on the use case saying, hey, camera, do you actually see a fire? Do you see a gun? Do you see a scratch? Do you see a car going in the wrong direction? Do you actually see something or the other? And then what if you had the ability to keep prompting the computer for responses that would make your cameras even more intelligent? So nothing changes. You still have the consume track, you still have the create track. This is an image chat, which actually works with the Ready Now models. It actually fuses the large language models with the AI models. And all of a sudden now, you can actually mount it on object detectors and things like that, and start to have those actually interact with the cameras real time. Now, the inferencing would still actually provide the insights, the smart analytics would still report it, but now you have something which is game-changing, which is a computer vision AI model fused with large language models for further insights and actions. Now, what is the implication of all of this, right? Let's actually see it. So now you can start to talk to images and they talk back. The cameras become more intelligent. You've now taught the computers what to say, what they see. which is now you've taught the computers not only to see, but to even say to you, because again, like we said, humans think in languages. So now you could actually have the same workflow as you can see here, with an addition of ImageChat added to this whole thing. Why is this important? It's important because most of the folks on the detection side and recognition side want to see instant detection, instant recognition, and they want the ability of humans to start interacting with it, whether it's a training requirement on the shop floor to even retail. You have just so many use cases that could actually use ImageChat. Now, when we move forward, let's try this again. Yeah, you actually talk and text with images, they talk back. So now the same millions of videos still getting stored, but now you have a computer that can automated on a text prompt basis start to actually prompt the cameras or prompt the images for responses. So now you are able to still detect, understand, and act instantly. In fact, now what you've done is you've got the cameras just like the eyes, you've got the computer to understand just like the brain does, and clearly you want humans to act just like humans should. So nothing changes, but you get this AI revolution, which has large language models fused with it. The implication is that every enterprise needs one. Now, think of it this way. You're an enterprise. You have millions of camera feeds coming in. It's storing millions of terabytes. You've got lots of people looking at it. Now, if you get an ImageChat supercomputer, as we call it, you have your own AI vision supercomputer. Your enterprise data is highly indexed and classified. You now can create prompts for what you want to see, and you receive very specific insights that can actually promote action. So what you've done is you've created your own custom enterprise super transformer model for your enterprise. Take it to your logistics warehouse and ask it questions, you get the answers back. Take it to your shop floor on the retail, you ask questions, you get back responses. You take it outside, you take it indoors, you ask your respective prompts, and you get those responses back. So it's your data, highly indexed, highly classified. You create the prompts, you receive very specific insights. What does it help with? It eliminates model building requirements. Your tech costs go down dramatically. Your need to hire people to actually create models, test them, deploy them, actually drops dramatically. So both on the time axis and the cost axis, you actually are able to see dramatic reductions. You're also able to dramatically reduce and eliminate people looking at feeds, because now the computer is actually texting back and forth with the camera streams to get the insights that you need. You can automate the prompts, you can automate the actions that follow. And the ImageChat 1 has got 11 billion parameters, 400 million images, recognizes over 40 million visual details. While we are going to show you ImageChat 1, rest assured, we've already started to work on ImageChat 2, which is actually about 10 to 25 times even faster and even more powerful than what we're going to show you in the next 15 to 20 minutes. So the implications are great. Every enterprise will have their own AI supercomputer, as we saw. And let's now actually jump and look at the demo. I'm going to request Emrah to show you the demo in real life, the workflow, how easy it is, and of course, showing you a live demo of how he's going to text those images and how they're going to talk back. Over to you, Emrah.
Thank you, Anubhav. Great to see you all. Let me just start sharing here. Hold on, just 1 second. Yeah. So yeah, the demo, we're really in this business about teaching computers what to see. That has been the mission of the company since the beginning. So, and we, in our journey, we ran into a lot of, let's say, experiences moving into that type of understanding and that type of visual detail. One of the things that we understood was what Anubhav said was that humans see with their eyes, but they actually understand with language. So that was really a eureka moment for us. And we knew that was coming, but it was impossible to put those together, to fuse the computer vision models together with language models until about last year, early last year to be exact. And then the second thing we understood was everyone wanted something else from their images and cameras. So if you're a product person, you're looking for something else in the videos. If you're a law enforcement, you're looking for something else in videos, and it could be the same video stream. If you're in a medical field, you're looking for something else. If you're in logistics, so poor camera, you have one camera looking at things, but everyone's trying to extract information from it, which is also a very difficult thing to do. So the challenge here was, how do you build a computer vision foundational model, which can be used for many, many different use cases very easily, or at least fine-tune for them. And here what you're seeing is something we're working with California Kern County with, and this is for fire detection. This is from 1,000 streams coming through to the Chooch API and pinging the API. And we've been working on this project for a while now. And so here, what you see on the left is a stream coming in, and the workflow is very basic. The stream comes in, you have the Ready Now ImageChat model. It's an ensemble of image encoder, it's LLM, it's a query transformer and object detector, all in one single model. It's a super ensemble model, and it's prompted with, is there fire or smoke? So here, the issue is, how do you create a computer vision model with text prompts? Something that we've never seen ever. In the past, what we've seen is collecting information, collecting data, annotating it, and so forth. And now we're able to create models with text prompts, and that's the main thing here. And here, we've created this model by saying, is there fire or smoke? And then the output is, yes, there's smoke. It's very basic. The output is basic. And then you have the bounding box here with the chipped image of when it sees that there's smoke. So here is something that you can understand how the workflow would work for other use cases as well. So how do you get to this point? How do you create a model with a text prompt? And that's kind of the whole thing. And we call this prompt engineering. And as we mentioned before, it's computer vision AI models merged with large language models for that type of insight. So move into here. And so this is the Chooch AI Vision Studio. You can log in today and you start using it. And basically, you have over here the ImageChat Ready Now models. You have other custom models, data sets where you create data sets. You have devices where you can set up devices, orchestrate the streams, orchestrate the models as well. You have raw data which you can upload and play around with in terms of creation of those data sets. You have synthetic data tools on it as well, where you're creating these types of models. So here, what we're going to do is we're adding an ImageChat 1 model, and this is to create something new, and basically you're creating a custom ImageChat model here. In this case, you name the model, and here we name it smoke detection, and you can name it whatever you want. You can name it corrosion detection, fall detection, whatever your use case may be. You can name it that, multiple use cases as well. And then you select an object detector, and this is optional. And the option here is whether you want the localization of that specific thing or not. And sometimes in most use cases, we do recommend that you select an object detector. And here we're going to use one of the Ready Now models called Fire and Smoke Detection 2.0. And then you can play around with the parameters and so forth within the object detector as well. So if you're kind of nerdy, you can play around with these and make sure that it works for your use case. And then you basically select the classes, and they all come selected default, but you can pull them out if you want, if you don't want one of these classes to be localized. And then here's where the magic really happens. And the magic is you're creating the model now by asking a question. In this case, is there smoke? But you can also ask, are the boxes stacked properly? Is there danger? That's pretty abstract. Is the person wearing safety gear? Is there trash? Is there a fight? You can ask all these questions with the prompt. And that's where you create that's how you create the model itself. And then once the model is created, boom, it's over here. And then basically what you're doing, you can go back and test it here. and this is the regular type of scene that you see when you have a model on the Chooch platform. You test the model. You can see here that which object detector it's tied to, the parameters, and then you have your prompt questions. Is there smoke over here? You go ahead and test it with an image, and then this is what you're getting as a response. Is there smoke? And the response here is yes. And then you can do your validation checks and so forth. And then you can tie this into your streams and into your APIs as well as you move forward. So let me stop sharing this, and I'll go directly into the system itself. Yeah. So here you can see our dashboard, the Chooch AI Vision Studio, and I've created here fight detection, but I'm going to create another model, and I'll create is there corrosion? Just corrosion detection, to be exact. So I've named it, and now I am selecting an object detector. I'll select one of the ready now models. Let's do general object 2, and you can select your own. If you've created your own, you can select that as well. And then you can see here all the different classes in this. You can deselect them as well. And then you have the parameters, you can discard keywords. This is for filtering. You can discard the prompts as well. And then let's move forward. And this is the prompt, right? So you just ask, is there corrosion? Yes or no? Don't give me a long answer. Just tell me if it's yes or no. And then you create it. And here you see that I've created this model. And you can see the classes in there. You can see the prompt question. Let's go ahead and test it. So I've got a few things here. Let me put up a few images. So you could see the output. Is there corrosion? Yes or no? Yes, and it's a 99%. Let's look at the second one. This is also, is there corrosion? Yes. And then this is a third one where there's no corrosion, and you can see the localization as well over here. So it's asking, is there corrosion in the main image? Is there corrosion in the chip in one of the objects, which is the hand? And then is there one with where the product is actually as well? And then you can also see the JSON response here. And this is for machine-to-machine tasking. And you're able to take this and use it however you want as an end user as well. So this is the creation of the model with text prompt. I'll go back to the here, and let's talk a little bit about the performance. So the question is it affordable? Is it usable? Can I use it out of the box? And here, this Enterprise Edition is on the cloud or on-prem. We can deploy in both environments. And it's really optimized for that type of capacity environment for production. And the reason is because we have been in the video business for a long time, and we've optimized all of our inference engines and all of our studio engines for this task. And you can see here, so inference speed is 0.2 seconds. That's even if you throw in 50 images, you're going to get a response in about 0.2 seconds. We recommend the A100 for here. So that's really what we're talking about. It's a dedicated A100 server. You can use a Chooch cloud, or it can be deployed on your own cloud as well, or on-prem for your own A100. And the capacity here is X times Y equals Z, prompts X, images Y, and then you can make the calculation. If it's one prompt and 50 images, that's kind of where your capacity is. You can do 2 prompts and 25 images and so forth. So it's highly optimized for video and highly optimized for large scale deployments. And so, yeah, you can download it as Wes mentioned. This is a watered down version of the Enterprise Edition on the App Store and Google Play. You can use it however you want. It's a fun toy, but the real enterprise play here is actually creating the model with the prompt. And that's kind of using all these different mechanisms that we create, the pipeline, to be able to do that and deploy it for those real life solutions. So with that, I think we can move on to some Q&A. Wes, over to you.
Yeah. Well, Emrah and Anubhav, thank you so much for walking us through that. Emrah, thank you for giving us a demo as well. So just a few questions that came in. One of them is, how will ImageChat differ from GPT-4's image to text feature? Could you talk a little bit about that?
Yeah, sure. I could take a stab. So the image to text, there are 2 things. First of all, the image to text is not public yet on on GPT-4. We don't know exactly what it's going to look like. However, based on some of the insider info we're getting is that it's the context for that is more storytelling. It's longer sentences. And it's more for creator tools rather than computer vision itself and these types of tools. Second is also the load and also the ability to do video on-prem. And we don't see that with the GPT yet, that they can be on the edge or on-prem. So those are the 2 main things. But yeah, it is. We're expecting them to come out with something similar or sort of in the same space within the next couple of months.
Yeah,
okay.
I do. I absolutely want to add to what Emrah said. There are two main differences as well that you should take home: speed and costs. If you take the X times Y times Z based on how GPT is actually pricing it, assuming it'll be available, it'll turn out to be more expensive than the offers that we have actually started to see success in the market with. The X times Y times Z is a very important thing. It's the number of images being inferenced in a particular time frame for what kind of results. If you take the GPT-4, please feel free to go on their pricing and et cetera, et cetera. You actually do that pricing. If you're willing to pay that price to us, we'd actually gladly take it. Our pricing is a lot more actually efficient. That's one. So that's on the cost side. The speed side, they're inferencing much more slower than we are inferencing. Why? Because they have not actually put the patented technologies from an object detection standpoint, the image optimization and all of that stuff. This is not easy. These are ensemble models that are actually fused. These are encoders. These have got fused large language models. And again, the speed of which slows down, the images. So what Emrah actually showed you allows you to sample 1,000 cameras in less than 15 to 20 seconds for a single prompt. That speed, when you actually apply GPT-4, only because they don't have the optimizers, actually goes by about 100 times higher. So in mission critical detection capability or recognition capability, you need a much more faster system. So think about speed, think about costs. Both of them are extremely important.
Yeah, thank you guys. And a very interesting question that came through was, do we see this technology rendering traditional model creation methods obsolete? And I think this is really more about the future of prompt engineering and how we see model creation playing out in the computer vision space. So I'm curious to hear your thoughts on that.
Yeah, it's a very exciting time, and we think eventually that this type of prompt engineering will take over the the classical model creation. It's not there yet. You do need to fuse a lot of the object detectors, and you need to localize, and you need to segment out, and you also need to train the transformer with the image encoders for certain use cases. So you're always going to need some type of annotation, some type of data set creation, and those are getting actually a little bit more complex with this, but it's getting a lot more accurate. So one of the issues in computer vision in general has been accuracy issue for some of these good use cases. And so with the transformer model, you're seeing an increase in the prompt engineering, yes, but you're also seeing an increase in more data sets and also more data sets creation and so forth. So it's not a one-on-one correlation. Actually, the universe of this is growing, and so that's very exciting for all of us, as long as we can answer the critical problems our clients are facing today.
Yeah. Thanks, Emrah.
Yeah, I mean, the success that we have seen with our clients is on ensemble models. These are ready now and on the custom side. These are exactly like Emrah said, more complex. They have large data sets, large AI models all working in concert with each other. ImageChat 1 is for object detection and recognition. So think of ImageChat 1 as something you can quickly deploy on our ready now models for detection and recognition. ImageChat 2 and 3 will clearly be a lot more transformational as they move into that field. But yeah, for now, I think that's the way to think about it, as you think about your computer vision journey with us.
Okay. Yeah, thank you. We had a question from someone who's joined several of our webinars. They asked if this particular functionality is also available through analytics. How incorporated is it into the rest of the platform?
Yeah, good question there. So the analytics currently feeds from the inference engine, and we're in the process of implementing that over the next couple of weeks so that it becomes more fluid with analytics, smart analytics. Smart analytics itself is a different product. It's quite complex, creating those analytics. And we in our journey, we found out that was very important for our clients. Now that you're creating all this new data for them, what are they going to do with it? And I think a lot of people trivialize that. So we had to create that analytics, but this also feeds into the analytics. It's just a matter of how you represent that. If it's a binary, you represent it separately. If it's a language output, you have to represent that separately as well. So that's currently in process as we implement.
Great.
Yeah, and actually feel free to use your own analytics engine as needed. We can actually provide the responses. I mean, smart cities have their own analytics dashboards, retail, manufacturing, inventory counting, and all of that stuff. So feel free to have your own analytics as well. These things can just take actually can take the inputs fairly quickly and actually integrate with your dashboard so that you don't have to create another one.
Yeah.
Yeah, thanks, guys. Yeah, a question came in, and great question, is about early use cases and proven value. Someone mentioned satellite imagery is a great market here, and we've already been working in satellite imagery with some of our existing features. And so, yeah, talk to us a little bit about where are we seeing some of that proven value with some of our partners and customers.
Yeah. So, we like to start out really small and basic, and the most basic use case was fire detection. And that's something that was in the pipeline for a long time, actually since the 2018 fires. So that deployment happened, and we're basically getting feeds from 1,000 cameras right now every 15 minutes. And that's working almost perfectly at 98-99% accuracy. So it's very, very highly accurate. And so that's one. Another is danger detection, inventory counting. It's basically fall detection, things that are more common, fight detection, weapon detection, and so forth, where we're seeing a lot of very, very high accuracy without the need to train a model from scratch. And so that's kind of where we're seeing all the, but it'll get more complicated as we move forward in terms of which use cases. Satellite imagery is one of them, just on a call the other day, talking about that. We already do pattern of life changes through satellite imagery. Satellite imagery is slightly different. They're very large images, geotiff and so forth. So there's a lot of stuff going on there. But if we feed it into ImageChat, we're getting a lot higher accuracies on all levels.
Yeah, and actually, that's really right. And most of our partners right now are actually putting ImageChat in their showcase in their labs, and actually in the executive briefing centers to showcase their clients. One of the partners is actually looking at anomaly detection on the assembly line. Are there cracks on a product, etc.? That again, a computer can easily be, asking the camera streams, the question, pinging them and saying, "Do you see a crack? Do you see a crack? Do you see a crack?" And you actually get an automated response. We have another partner actually that's actually implementing this on the Space Force side, exactly like actually Emrah was saying. The goal is right now to create the custom AI models, but then eventually, have these very, very specific questions that you want answers. And again, clear, kind of a machine-to-machine interaction that's taking place. And then there is another partner right now, which is actually implementing ImageChat in their labs, which is looking at actually product recognition, out of stock inventory. I mean, is there enough stock in the racks? Yes or no? Yes or no? And simple yes or no answers actually eliminate so many people's the need to have very expensive technology, very expensive costs, and lots of people just looking at screens to see that, hey, has the inventory shrunk to 75% levels, 50% levels, 25% levels? You could easily get a computer to ask those questions and get the responses back to you. Again, we have to give technology what technology does best so that humans can do what humans do best. And you're almost actually, transferring that, that human intelligence to computer to do what they could so that, human lives actually improve. Revenues go up, the cost of operations go down, security goes up, so on and so forth. I mean, we have one of our partners, clients actually, which is looking at, falling totes right now. And, if you actually are stacking up baskets and they're leaning, it's very easy for a camera to say, hey, the lean index is very, very high, and hence something has to be done about it before they actually fall and actually injure people and break stuff. So again, a simple question like, are they leaning? Yes or no? And the moment it gets yes, boom, you get the prompt, and then you can actually work on it. So again, outsourcing to the computers to do what they do best so that humans can do what they do best is the goal.
Yeah, thank you. This next question is maybe just a little more technical in the features, but how long has ImageChat been learning? And if it is a question that can be answered, how far along is it for all reliable practical use cases?
Yeah, good question. So it has been learning for many, many years because the data sets were being created over time. And there are parts of the data sets that we've created and part that are open data sets that we've collected as well. So the data sets have been curated over many, many years. The training itself happened over a month and a half. The training with all the ensemble. So this is ImageChat 1. And so with ImageChat 1, we have 11 billion parameters on the language front, the query front, 400 million images with the image encoder on the image front. So it can do about 40 million visual details. But ImageChat 2 is coming up. We're in the process of training that. That will have 2.5 billion images, which means it'll be probably 5 to 10x smarter than this one. The goal here is to continue feeding it more information so that it becomes more omniscient, better cognition, better accuracy, without having to detract from the fact that it needs to be usable, because the bigger these things get, the more unwieldy they get as well. So we want to be able to put this on-prem, on edge, and so forth. And that comes mainly from the language models, actually. If the language model is too heavy, you can't move it around. And so for us in computer vision, the language model is limited. We only want, short answers. You want yes, no answers. You want to be able to, you don't need to write stories about an image or a video coming in our use cases, usually, because you need someone to interpret those images, interpret those paragraphs as well then. So you need to put another language model to interpret, to kind of summarize it. So we don't want to get into that. And so we're looking at still 11 billion parameters on the language front for ImageChat 2, but it'll have 5 times more the 6 times more the images with the image encoder. And then you have the object detector, and that goes into the one more question that we have up here, which is how do you handle inventory? So with inventory, you need to have the object detectors. You cannot do inventory without object detectors currently with transformer models. It's just not possible to do that, only with the transformer itself. So the object detector needs to understand the object, whether it's in front of it or it's sort of obstructed as well, and then be able to understand, classify that, what it's looking at, and then do a count of it, basically. So there, the object detector and inventory counting is you have to have it, and you can use the some of the pre-trained ready now object detectors, but in most cases where you're doing inventory for particular retail use case or warehousing use case, you're going to have to build your own custom object detector just to localize to look at the object, and then use the rest to kind of classify what you're looking at, even if it's obstructed. So I think there was a question on that as well.
Yeah. And, everything that Emrah said, is complexity simplified, right? So in our case, we've taken all that complexity that has existed over the years in computer vision, we've simplified it. And some of our mentors would share, fine, you've actually solved for the complexity, can I afford it? So it has to be economically viable as well. So for a few dollars per camera per month, you can actually, you can actually have this installed. So your AI vision supercomputer doesn't have to be a very complex project and doesn't have to be a very expensive project. It's extremely important. I mean, when we were pre-launching ImageChat, a couple of weeks ago, we were actually running it by analysts and our partners and our customers, and we were seeking lots of feedback. We did have a pricing table that we were able to share, with each of them. And the common feedback we got from everybody was, hey, 2 things. One, you seem to have taken all that complexity and all the years of learning and training, etc., and actually make it very simple to actually deploy, which is great. But most importantly, you've brought it to a price point which can be mass adopted at scale. So technically feasible being one thing, economically viable being the other thing. I think the economics of this offering also is very attractive.
Thanks, guys. Yeah, I mean, what I particularly love about this is with the prompt engineering side of this, we're really lowering the barrier of entry to building computer vision models, which is part of the mission of Chooch. And I'm excited, and as well as everyone who's been on this call, excited to see where this goes. So thank you so much. So for everyone who's joined and stuck around, thank you for making time today. Again, there were some questions that we can follow up with after this call, and we'll be reaching out to you shortly. But Emrah and Anubhav, thank you so much for taking the time. And we will end here. So thank you, everyone.
Thank you, everyone. Best of luck.
Yep.
Good day.
Yep.
Thank you.